So, what did you think about parallelograms?
I hate parallelograms. They're stupid.
Well, today is rectangles. That should be better, right?
I guess. I'll watch note 7 too.
All right, guys, so today we're doing note 7.2. We're going to talk about rectangles. The actual definition for a rectangle is a parallelogram with 4 right angles. So I can draw a rectangle. It's just specifically these have right angles at every corner, okay? Because a rectangle is a parallelogram, all the properties of the parallelogram we talked about yesterday also apply, but since it's a specific type of parallelogram, it has its own little special relationships. It says first, name the diagonals of rectangle L, M, and O. So I'm going to draw the diagonals in here. Looks like one of my diagonals is segment OM, and the other diagonal is segment LN. Now we're going to find the lengths of these diagonals, and the way we do that first is we have to have the coordinates of each of the points. So we're going to start with OM. It looks like the point of O is going to be -6, -3. And then the point M, I'm going to put O out here so we remember, M is 4, 4. And to find the distance, we're going to have to use the distance formula. So I'm just going to label these x1, y1, x2, y2, and then I'm just going to fill out the formula. So the distance is equal to the square root of x2 minus x1, 4 minus -6 squared, I got a boom boom, plus y2 minus y1, 4 minus -3 squared. Got another boom boom there. So I'm going to go ahead and do the addition. Looks like I have 10 squared plus 7 squared. That's going to be 100 plus 49. And that's going to be the square root of 149. And we're just going to leave it at that. If you want to put a decimal there, I'm not going to be upset about it. Now let's look at the other one. It looks like LN. So L looks like -6, 4. And N looks like 4, -3. And make sure you count really well on these on the homework, because if you mess up the points, you're going to miss the problem. So let's see. Distance equals the square root of 4 minus -6 squared. Got a boom boom. Plus, looks like -3 minus 4 squared. So I do my arithmetic. Looks like I have 10 squared plus -7 squared. That would be 100 plus 49, which strangely is 149 as well. So if you notice, these are the same. And that gives us one of our rules that's specific to the rectangle. It says we can say that if a parallelogram is a rectangle, that its diagonals are congruent. So that's a pretty important one. Now, I've got a picture of a rectangle down here. Remember, everything that happens on a parallelogram happens here, but there's a few other ones that are pretty important as well that are specific to the rectangle. So the first thing we know is that opposite sides are parallel. We had that yesterday. There's going to be a lot of marking on here. Opposite sides are congruent. You already knew that about rectangles, I'm sure. Opposite angles are congruent. And since they're all 90 degrees, I'm just going to do that. Says consecutive angles are supplementary, just like yesterday, so they add together to get 180 degrees. And then it says diagonals. We also have that diagonals bisect each other. So I know this is congruent to that, but since it's a rectangle and the diagonals are congruent, all these are equal as well. Then it says we have 4 right angles, which we just put in there, and we have that the diagonals are congruent, which we've already marked. Let's go to the next page. So we're just going to answer some questions using those properties we just learned. It says quadrilateral MNOP is a rectangle. It says MO, so that's a diagonal, is M to O. So this whole thing right here is 2x minus 8. And then it tells me that NP, the other diagonal, it's kind of hard when you get on there, is 23. And it wants us to find x. Well, I remember from the last page that diagonals are congruent. So I'm going to set these equal to each other. 2x minus 8 equals 23. That means 2x equals 31. That means our x value is going to be 15.5. So pretty easy. Things being congruent is nice. Now this one's a little bit tougher. It says quadrilateral JKLM is a rectangle. From L to P is 3x plus 7. So that's just this one little piece right here. 3x plus 7. And then it tells me that the whole diagonal from M to K, so this whole thing, is 26. Now this is sort of like problems we've done before. I need to remember that this diagonal, or it's half a diagonal, is equal to this one. So I really have 3x plus 7 here as well. So I need to add those two pieces together and then set it equal to the whole of the other one. So I'm just going to do 2 times 3x plus 7, because that's what it is, equals 26. I'm going to distribute, so 6x plus 14 equals 26. Subtract the 14 from both sides, 6x equals 12, which gives us x equals 2. So fill out your picture, guys, and be really careful when you're doing that. We had a lot of problem with realizing, okay, this part's 3x plus 7, so the other part is 2, okay? Let's go to example 3. Quadrilateral ABCD is a rectangle. It says the diagonal AC is 4x minus 13. Then it tells us that from D to P is x plus 7. And it wants us to find x again. So similar problem, right? Since this is congruent to that, I know I have 2 x plus 7s. And that the other diagonal total is 4x plus 3. Now I can distribute and solve. So it looks like I'll have 2x plus 14 equals 4x minus 13. I don't know where I got that 4 from. Minus 13. Sorry, guys. Now I can move my x's to one side, my numbers to the other. I'm going to subtract 2x and add 13 at the same time. So I get 27 on one side and 2x on the other. And when I divide by 2, I get x equals 13.5. So not too tough, guys, but I do want to point one thing out. Every one of these said the quadrilateral is a rectangle, so you're going to have to be really careful to that. Today we're just talking about rectangles, but we're going to start talking about more and more quadrilaterals. You need to make sure you're talking about the right one. This problem, it's got a lot of stuff on here, but rectangles are pretty easy when it comes to finding the angle measures. It says we've got a rectangle KLMN, and it gives us some information. It tells us the angle 1 is 70 degrees, so I'm going to fill that in. Then it tells us angle 7 is 20 degrees. And it wants us to find all the rest. I guess the most important thing to remember on this is that all the angles are right angles. So their sum has to be 90. So if I want to find angle 2, I take 90 minus 70, and that gives me 20 for angle number 2. And then I can kind of work my way around doing the same thing. I'm going to go ahead and find angle 8 because it's pretty easy. If angle 1 is 70, then that's going to mean angle 8 is also 70. Okay, you can also see, okay, those should add up to 90. But think about some parallel lines cut by transversals. You have some alternate interior angles running around in here too. Like 2 and 6 are alternate interior angles, therefore they are congruent, making angle 6 20 degrees. And that means angle 5 70. It's also alternate interior from angle 1. Angle 3 and angle 7 are alternate interior, so that's going to be the same. It's going to be 20 degrees. And angle 4 and angle 8 are alternate interiors, so they're both 70 degrees as well. Now that leaves us with angles 9 and 10. We're going to have to use some knowledge of triangles to find this one, but it should be pretty easy. I have this triangle over here. I'm going to call it triangle LCM, that one right there that I outlined in blue. The total should be 180 degrees. So if I take 180 and subtract both of the other angles I know, which are both 20, that leaves me with 140 degrees for angle 10. Now, if you notice, angle 9 and angle 10 are across from each other. They're vertical angles, so that means angle 9 is also 140 degrees. Now, you didn't have to use any of that alternate interior angle stuff on this one or the parallel lines. You could have just realized that there's lots of 90 degrees running around, but I do think that makes it a little bit quicker. So we've got our last one here. Quadrilateral RSTU is a rectangle. It says if the measure of RSU. So I had some people have some problems with this the other day. Angle RSU starts at R, goes to S, and ends at U. That means this right here is 3x minus 5. Then it says UST. So UST goes from U to S to T and makes this our angle, 4x plus 4. Now, we need to solve for x, I think is what it says. Yeah, find the value of x. So you should know already that all angles in a rectangle are to have a sum of 90 degrees. So we can add 3x minus 5 plus 4x plus 4, and we know that should equal 90. We can combine like terms. We get 7x minus 1 equals 90. Add the 1 to the other side. 7x equals 91, and divide by 7 and get x equals 13. So rectangles are pretty easy, guys, but the problem is going to be we're going to have lots of these quadrilaterals that are also parallelograms. Your rhombus and your square are as well, so make sure you can differentiate between all these quadrilaterals. All right, guys, good luck.